Welcome to my channel. In this video we are going to prove this expression by using mathematical induction. Well, how to begin? So we have some steps. First step is the basic case. We know in the beginning we should prove this expression is true when n is equal to 1. So let's check. When n is equal to 1, I am going to take left hand side. We know here r is equal to 1, here 1 over r plus 1. Now if we plug in 1 here, because r is equal 1 to 1, so we have 1 here, 1 plus 1 2, so 1 over 2. Now RHS right hand side, we know 1 minus 1 over 1 plus 1, we know 2. So 1 minus 1 half, we know 1 over 2. Now we know left hand side is equal to right hand side. So the first case, the basic case, is true. Now next step, we assume when n is equal to p, when n is equal to p, p is also a positive integer. When n is equal to p, we assume this expression is true. This expression is true. Okay, so we can write r is equal 1 to, now here p, r is equal 1 to p, 1 over r plus 1 is equal to 1 minus 1 over, now instead of np, so p plus 1. Okay, the final steps, we know we should prove this expression is true when n is equal to p plus 1. So to prove this step, first I am going to take this part, this term is equal to ur. So we can write ur is equal to 1 over r plus 1. Then we should prove when p is equal, n is equal to p plus 1. Then here take u p plus 1. We can write 1 over p plus 1 p plus 2, because instead of r now we plug in p plus 1. So now as a next step, here r is equal 1 to p, 1 over r plus 1 plus, now take add this part to both sides. So here we have 1 over p plus 1 p plus 2, and this is equal to 1 minus 1 over p plus 1 plus 1 over p plus 1 times p plus 2. Now here we have sum of r is equal 1 to p, 1 over r plus 1, and we know this is next term of this series. So we can write this is equal to r is equal 1 to p plus 1, 1 over r plus 1 is equal to, now here we have 1, so I am going to take 1, and now for these two parts we can take 1 over p plus 1 as a common factor, so 1 over p plus 1, and here now we have 1 minus 1 over p plus 2. Okay, now we should simplify. Here we can write 1 minus 1 over p plus 1, and here p plus 2 minus 1, p plus 2 minus 1, we know p plus 1 over p plus 2. Now we know this p plus 1 get cancelled, and now we have here sum of r is equal 1 to p plus 1, 1 over r plus 1 is equal to 1 minus, now here we have 1 over p plus 2, 1 over p plus 2. Now here 1 minus 1 over p plus 2, we can rearrange p plus 1 plus 1. Now our question, sum of r is equal 1 to n. Now instead of n we have p plus 1, and right hand side 1 minus, so 1 minus 1 over n plus 1. Now instead of n we have p plus 1. So we are done. If you like this type of videos, please subscribe this channel. Thank you for watching.